Okay, so we are finished with activity 4 and we're moving on to activity 5. Okay, in activity 5, we're going to be doing a lot of stuff with functions. So if functions have been confusing you for a little while, hopefully this will help clear some things up for you. You can get a deeper understanding on how they work, and we're going to be using them to model some real world scenarios. So hopefully that'll help you as well, just have a real world grasp on it. And functions are really handy. We actually use them every day. We just don't realize it. And so this math usually gives real world things a structured way to view them instead of it being this kind of like vague thing that you do in your head. So that's why it's important for you to show your work. So our learning targets here, we're going to be doing operations with functions in this lesson. In the Khan Academy videos from last week, you saw some examples of this. So hopefully we can get through this rather quickly. So our learning targets are to combine functions. We're going to combine functions using arithmetic operations. And that's things like, add, subtract, multiply, and divide. The 4 basic operations you've been learning since elementary school. And then we're also going to build functions. We're going to write these functions ourselves. And they're going to model real-world situations. So before I dive head first in here, I want to remind you of a couple things. In the warm-up video, I talked about like terms. I hope you watched that. Like terms have the same variable and exponent. So before you can add two mathematical terms, they have to meet this requirement. And it's like apples and oranges. And if I put 2 apples together, it's 2 apples. But if I add an apple and an orange, well, that's just 2 separate things, an apple and an orange. It's just one way to, it's not fully an analogy, but it's one way to think about it. So function notation, which I have talked about before in previous videos. Recall function notation. Function notation looks like this. F of x equals whatever your expression is, okay? The letter that's in the front here, that's just the name of the function. The letter that's inside is the actual variable, okay? This is your input variable. And then the result is what you get after you input, that is your output variable. So you can have stuff like h of z equals r. I'm just kind of making up some letters here. In this case, h is still the name, our input variable is the z, and our output variable would be the r. It doesn't really matter what letters they are as long as they're, defined in the context of whatever the problem is. R of t equals s. Okay, so just to point out, this is not h times z, this is h of z, f of x, r of t. We don't write it out because we're trying to save time. We don't have to write of every single time when we can communicate the idea without it. So in our problem here, we have a real-world scenario of Jim Green has a lawn service called Green's Grass Guarantee. It's called alliteration, by the way, just so you know your math teacher is good at English too. Tori and Stefan, I like Stefan more than Steven, are 2 of his employees. Tori earns $10 per hour and Stefan earns $8 per hour. Jim sends Tori and Stan to do a job that takes them 4 hours. So they're going to do a job that they're together. Together, this job takes them 4 hours. Okay, not that the job can be done with one person in 4 hours. Together, Tori and Stefan will take 4 hours to do this job that their boss, this is their boss, he owns it, right? Jim Green owns it. Sends his 2 employees to do a job that takes them 4 hours. So first we're going to write a function t of h to represent Tori's function. So in this case, we're talking about T, which would represent the name, which is Tori. And then if you keep reading, earnings in dollars for working H hours. So H inside the parentheses, our input is hours. Okay? So T of H. Okay, so we're talking about Tori's, that represents Tori's earnings for working H hours. So how much does Tori get paid again? Well, up here we saw that Tori gets paid $10 per hour, so that would be 10H. And then it also says to write a function, S of H, to represent Stefan's earnings for working H hours. So, see, we still have S for Stefan here. And then the input variable is H for hours, your input. Okay, so we input the hours, and the output should be their earnings in dollars. So Stefan gets paid $8 per hour. So for S of H, we'll write 8H. So this guy right here is for Tori. This one represents Tori's earnings. Okay, and this one right here represents Stefan's earnings. Okay, then down here it says find T of 4 and and S of 4. Tell what these values represent in the situation. So remember what I said about this is the input variable, okay? What's inside the parentheses is our input. So it looks like we're going to be inputting 4 for Tori and 4 for Stefan. Where did that 4 come from? Well, up here, remember we said it takes them 4 hours. In the top right, you see it? 4 hours to do the job. So we're trying to find out how much they'd earn. We're trying to find their earnings. So Tori, T of 4, is going to equal, so I'm using the top one, and I'll do it in green because that's where I started. So we're going to take Tori's and do 10 times 4 to get 40. So Tori would earn $40. That's what it represents in this situation. And then for Stefan, which is in red, S of 4 is going to be 8 times 4, which would give us 32. This means that Stefan would earn $32. Okay, so far we've written equations, we found out how much they would both get paid for working the job. And then down here, find T of 4 plus S of 4 and tell what it represents. So we're adding these two guys together that we just found, okay? And T of 4 equaled 40. We got 40 there. S of 4 equaled 32. So that means we could write that like that. T of 4 equals 40. S of 4 gave us 32, right? And so this is telling us to add those two things together. T of 4, which was the 40, plus S of 4, which gave us 32. So we're taking Tori's earnings and we're adding them to Stefan's earnings. So we have 40 plus 32, which is going to give us 72. So Tori's earnings plus Stefan's earnings is a total of $72. The total earnings for Tori and Stefan would be $72. Okay, so, why is this function useful? Who is this function helping? Yeah, I mean, Tori and Stefan know how much they make, but why would they want to, who needs to know what their total earnings would be? Let's think about the third person in the scenario. We've got Jim, their boss. He pays them. So Jim needs to be able to have easy ways to find out how much he needs to pay his employees without making a table or something like that. So these functions are useful because he can just plug in a number and there's his answer. So moving on here to 4. You can add any two functions by adding their function rules. What's a function rule? This is a function rule. This is a function rule. These are function rules. We talked about what a function rule was in the piecewise functions, okay? A function rule is just like, this is function t, this is its rule. This is function s, this is the function rule for that one. So you can add any two functions by adding their function rules. So we're going to add the functions t of h and s of h. So t of h, which if you recall was 10h, and s of h was 8h. So if I take those two together, t plus s of h equals 10h plus 8h, and that would give us 18h. So we just say the sum of function t plus s, the sum of function s and t and s of h would equal 18h. So basically like, hey, I added these two functions together, I got this. That's what we're saying. Okay, what does the t plus s of h represent in this situation? Okay, so let's recall. I've said it before, so I'll just kind of repeat it here. Remember that t represented Tori's earnings, and s represented Stefan's earnings. So if I add those two together, if I add their two earnings together, then this would represent the combined earnings of Tori and Stefan. Okay, so then it says here, number 5, what does t plus s of 4? So this is just saying take 4, plug in 4. Okay, so up here we've got that t plus s of h was 18h. We'll take that 4 and plug it in. T plus s of 4 equals 18 times 4, which is, guess what? Going to give us 72. So I write cursive T so they don't look like plus signs, I'll be honest. So compare this answer, the T of 4 plus S of 4, which was up here. T of 4 plus S of 4. Compare these answers. We got 72 up here, and we got 72 down here. They're the same thing. So basically we can conclude that T of 4 plus S of 4 equals T plus S of 4. They're the same thing. It's the same concept. I can either plug in 4 and then add them together, or I could add them together and then plug in 4. Okay, and then how much will Jim spend on Tori and Stefan's earnings for the 4 hours? So that would be $72. He would spend $72. So over here, if you notice, it talks about that some more too. We've got addition, subtraction, multiplication, division, or operations. Okay, you can also perform these on functions. Writing math, the notation f plus g of x represents the sum of f of x and g of x. In other words, is what we just said, f plus g of x is the same thing as f of x plus g of x. The notation means the same thing. All right, so at the underneath this video, I want you to answer this question. How much would Jim spend on Tori and Stefan's earnings? So this is their combined earnings. Their combined earnings for a job that takes 6 hours. So again, we're using the combined earnings, and that was 18h. And explain how you determine your answers. Our talk is 6 hours now. All right, you'll answer that in the text box below the video.